so this was part of last night's homework and the assignment you're working on that's due on Monday. That was not in the video, so I kind of wanted to go over it with you. So y'all all have that copy down? Not yet. The shapes, just kind of sketch them out. And then the writing, the main thing is the area of a regular polygon is going to always be 1/2 the perimeter times what's called the apothem. And the apothem is a specific length. It's the shortest distance from the center to one of the sides. So there are actually multiple apothems. So some of you are kind of talking about the radius. It's not exactly like the radius. I can see why you think it's kind of comparable to that, but that would be your apothem. Do I have others? Yes. I could also go this way. I could also go that way, but it has to be a perpendicular distance because it's the shortest distance from the center to one of the sides. So if I went from the center here to the vertex here, that's going to be what? A longer distance, right? Okay, does that make sense? So it's specifically the apothem. So that's the formula for the area of a regular polygon. So what is a regular polygon as well? Do you remember that?
A polygon is a shape with more than 4 sides.
Okay, very good. Well, a polygon is actually, a triangle could be a polygon as well. So you could have a regular triangle. What would that be called?
Equilateral.
Very good, equilateral. Basically meaning all sides are the same length and all of the angles are the same measure. Do you remember that? So these are all regular polygons that I have drawn up here. So I'm going to start with like a basic example here. Say our apothem is actually 3 here. So I'm going to tell you this is 3. And let's just say the side length is 5. So the area of this polygon is going to be 1/2 the perimeter. And you can do the P and A either direction. The perimeter is going to be what though?
25.
25, because I'm going to do 5 times 5. Just make sure you understand because there are 5 sides. And N is typically the notation for the number of sides. And then I also need to multiply that by what? The apothem, which is 3. So when I do this, I get 25 times 3 is 75 halves, which is 37.5. And be sure to put units squared. Because there's no verbiage there, so you don't know what the units are. So that is the basic one where you're given the apothem and you're given the side length.
Why is it 5 times 5?
Because you need the perimeter. So the formula here says perimeter. So it's 5 times 5. There just happen to be 5 sides and the length of the side happens to be 5. That's just a coincidence. Okay. All right. So that's the first example you might encounter. Another one is, say you're given this information and you're asked to find the area of that regular polygon. First of all, how many sides are there? 6, making this what? A hexagon, yes. Right? Yeah. Okay, yeah, hexagon. All right, so what information am I missing here, though? I don't have the side length, so I don't have the perimeter, so I can't use the formula. Let's go ahead and write out what we do have. Sometimes that's helpful to kind of get yourself started. 1/2, and the apothem here is 4. I'll go ahead and write that down. But I don't have the perimeter. How am I going to find that with the information that I've been given?
You split the triangles and then you do like
Okay, very good. Very, very good. So I am going to draw a little triangle here. Let me just kind of change the color a little bit so it looks a little bit different. So here, that didn't turn out very pretty, did it? Just because of where I showed it. So there is the triangle that we're kind of looking at. And this is a right angle. Okay, so I really am going to find this side length right here. Yeah, I'll have to multiply it by 2. Isn't that really just this one piece is just going to be the side? S is the length of your sides in a polygon. So I'm going to find S over 2. So once I find this side length, let's just call it X for the case of just like solving. I'm going to double it, and that's going to give me the side length. So then I'm kind of in the same boat as I was in the first example. But how do I do that? Like, how do I find this little angle measure so that I can use my sine, cosine, or tan of the angle to find the side?
You would have to.
Since the middle is 360, divide it by 6 times the 6, and you have to divide it by 2 again to get that one.
Very
which would
good.
be 30, and then you do the tangent of that, so it'd be like something, yeah.
Okay, very good. So
Yeah.
it is true that if you kind of think about this as a circle here, do you see there's 360 degrees there? Yes.
Where did you get the 5? The 5?
That's an S, sorry.
Oh.
That's an S, yeah. It's not a 5, it's an S. I'll try to, yeah, it's kind of hard to tell in it. Alrighty, so you have 360. So because there's 6 sides, there's 6 angles that are formed like here to here. Y'all have to really watch what I'm doing here, okay? So there's 6 of those that are equal in size, equal in measure. So if I divide 360 by 6, it's going to give me 60, but then, yes, you have to divide it by 2 always because that is an angle that's being bisected by our little design here when we drop the apothem here. So the angle measure is going to be what? 30. That's the most important thing to understand. The angle here is 30 degrees. So I'm going to kind of pull this little triangle out and draw it down here just for hopefully to help clarify some things. So I have 30 degrees. I need that. Do I have this? Yes, this is 4. So I need the opposite leg. I have the adjacent leg, meaning I'm going to use tangent. So tan of 30 is equal to what? X over 4. So then you're just cross multiplying. X is equal to 4 times tan of 30. Now, that is giving me just the half of the side. So don't I need to double that? Okay, so I'm going to double that without doing anything in the calculator yet. But then that's just giving me the side length. Now what do I need to multiply it by?
By 6.
By 6, by the number of sides. So 6 times all of that. Okay, so I'm going to go back and essentially just put all this in right here for perimeter. And then I'm just going to plug it into my calculator. So I'm not going to get a decimal here just yet. So 6 times 2 times 4 times tan of 30. Okay, so you can kind of simplify some things down. So 1/2 of 4 is just going to be 2. Times 6 is going to give you 12. Times 2 is going to give you 24. So 24 times the tan of 30. So go ahead and do that in your calculator. Now, one thing is make sure that in your calculator you are set to degree mode.
So it's what?
Degree mode. So it's the button in your calculator that literally says mode. Click on that, and there's radians and there's degrees. So your calculator, if you just got your calculator and you just put new batteries in it, or if you reset it for some reason, it goes right back to radians. Radians you don't use this year at all. Okay, so we're always going to be in degree mode. Yes.
Why are we using tangent and not?
Why are we using tangent? Very good question. Because remember our SOHCAHTOA, and if you haven't watching the videos yet, you may not remember this. Remember that sine is equal to opposite over hypotenuse, tangent of an angle is equal to adjacent over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is opposite over adjacent.
Okay, scratch that. I just made a mistake when writing out SOHCAHTOA.
Oh, I gotcha. Okay, so what are y'all getting on this one?
55.426.
25. Why am I not getting that?
I got 13.
Yeah, that's what I'm getting too.
13.8.
Are y'all sure you're not in radians? That's your modes.
13.85.
Yeah,
13.8.
13.8. You're supposed to be in degrees.
Yep. So 24.
13.
Times tangent of 30.
What do you get for tangent of 30? Oh, it's just tangent of 30. That's a mistake.
I got 13.8.
Yeah, I got 13.856. And this would be units
Oh,
squared.
Wyatt, I think we're tangent 30.
So you could just do the whole thing in your calculator as well, just all at one time, just to double check. Literally all of it just at one time, and
You get 13.8.
Yeah.
okay, but wait.
You bringing everything down?
When we do 0.5 times 4 times 6 times 2, I'm getting 50. When I do it with this whole string, I also got
I
55.
do get 2.
Yeah, I think it's 55. I think you're not bringing the 4 down to 24 and 30.
Maybe not. So that would have been 2 times 6, which is 12,
12 times 14 and 30.
times 2. Oh, yes, that's the 4 and a half. Yes. Okay, good. So that is, y'all are right. So if you did it this way, this is my mistake right here. That's where I made the mistake. And you can do it all at once in your calculator. And what are you guys getting?
55.426.
Yeah, I'll just erase all this and go straight back. So if you simplify it some, like I did, and make a mistake, then let me put the wrong thing. So 55 point, what was that?
426.
55.426. Okay, now, there's one other scenario. What if we are given that the side length is 8, and y'all, these polygons could have been any regular polygons. You have the same approach for each of these no matter what. I just chose 3 different ones so we kind of see more than one polygon here. Yes, Dave?
I forgot it. I'm sorry.
Oh, okay. It'll come to you. Okay, so if I have a side length of 8, what am I missing here? I'm missing the apothem. So area is equal to 1/2 the apothem. Do we already know the perimeter?
Mm-hmm. 8.
No,
the perimeter is
64.
Yeah.
Yes, very good. Because the side length. So all we really need is the apothem. Okay, you find the apothem differently than you find the side length. To me, it's actually a little bit easier. And here's why. Let's kind of draw it. So when you draw this, you're still creating this little triangle here that you're dealing with. Okay? Now, do we have this side length here?
Yes.
4.
We know the side length is 8, so half of it is going to be 4. So let me draw a little triangle here. So this is 4. What are we really looking for? We're looking for that. It's our apothem, so let's just go and call it apothem. Okay, now what's our angle measure?
30.
We could do 360 divided by what? 8, but then you have to do what? Divided by 2. Just go and divide by 16, right? And you get 22.5. So this little angle there is 22.5. So then when I'm trying to solve for my apothem, it's going to be tangent of 22.5 because we have the opposite and we need the adjacent. So tan of 22.5 is going to be equal to 4 over A.
So, and then with side we do divided by 4.
Okay, you can cross multiply, but there's an easier way to remember this. If you literally just exchange your A and your tan of 22.5, A is equal to 4 divided by tan of 22.5. Now, you can kind of prove it to yourself by cross multiplying and solving. You'll see you get to the same thing. But anytime your unknown is in the denominator, you can. It's due to the way that proportions work. It's one of the principles of proportion. So A over B is equal to C over D. You can actually exchange this numerator right here and this denominator and come up with this. So going back to this, all I'm going to do is insert this as 4 over tan of 22.5. Okay, so let's do all this in the calculator.
9.6.
We'll be careful. Let's see.
That's the apothem.
For the apothem, it's 9.65.
Okay.
And then you multiply.
Yes, that is 9. Now, and I would go straight in and multiply by what? 32. Very good. So the area here is going to be 309.02 units squared, just depending on however far you round it. All right. So that was in the assignment that wasn't in the video for the lesson. It was something that just we didn't get to in that yet. So anyway, there you go. So let's talk about